Hello again. I'm going to talk about the second part of my PhD work. And so I we have the daughter plants out of the production system. We're now looking to root them and send them off to a grower of some sort. So this fits within the objective two of we're looking at the impact of low temperature on early flower development in short day and everbearing strawberries. So in rooted plant production, with regards to how the plants receive low temperatures, they're harvested from the mothers in a greenhouse where the daughters are not exposed to any low temperatures. But then as they're rooting, they're put out onto a sprinkler pad. This is very common in trade plant nurseries in Northern Europe. And starting in early fall, late summer, they start to receive chilling hours or low temperatures overnight while growing during the day. And then any supplemental low temperature is delivered in the cooler. And then you have this rooted transplant with some meristems being floral, ready to grow out in fruit production systems. So what we wanted to know with these experiments, or what we wanted to address, is are both types of low temperature or chilling required in entirely controlled environment produced plugs? So when we take the plants from a controlled environment nursery, root them in a growth chamber, are we going to need continuous low temperature or day-night low temperature, or neither, to produce, in this case, a tray plant with floral buds? Beginning with that, we'll look at continuous low temperatures first. So knowing that low temperatures have to be used somewhat to induce flowering, we hypothesize that flowering can be induced through low temperature treatments in both short day and everbearing strawberry plants. And we wanted to evaluate the impacts of these continuous low temperatures on 4 cultivars: 2 short day, Chandler and Sensation, and 2 everbearing, Albion and Monterey. The plants were all collected from this indoor strawberry nursery grown by Ibrahim that you can see here. Again, we had 4 cultivars: Chandler, Sensation, Albion, and Monterey, and we had 10 plants per cultivar per treatment. At the beginning, we just took some initial measurements to quantify size again. So we took crown diameter, root number, leaf count, and fresh mass. The plants were then rooted for 28 days at 15 degrees Celsius. The short day or seasonal flowering, SF there, was rooted under a 12-hour photo period. And the everbearing was a 16-hour photo period, consistent light and CO2. At the end of the rooting, they were again measured for size. I'm going to skip and come back to that slide. The treatment in the continuous flowering, we had this cooler. The lights are on in the photo, but they were off during the treatment. So the plants in theory are not growing while they're receiving this low temperature. And they went into the cooler for 0, 100, 250, 450, or 600 hours. And at the end of the low temperature treatment, again, we measured it to ensure that no growth had taken place during this time. But after the rooting and before the treatments, the plants were grown out in a chamber like this for 28 days, for 4 weeks. And then after the treatments, they were put into the same chamber for another 4 weeks. And this chamber was at a cool temperature, 15 degrees Celsius. And because we have both the short days and long days in here, we had a 12-hour photo period, a higher light intensity in the rooting. And at the end, we took vegetative measurements as well as did flower mapping. And Ed did a good job of explaining flower mapping. I just have some photos here of what I did, and this is what my process looked like. I went ahead and dissected every possible meristem of the plant under each leaf and the terminal meristems. Even if they were dormant, I dissected them looking for the status of each meristem, whether that was going to be vegetative or floral. Here, as you can see, 3 different stages of floral meristems in the photos. And so when I saw a floral meristem, that was counted as a floral truss, and that's what I'm going to be reporting on in all these future figures here. So I'm not going to be reporting on the amount of vegetative meristems, but just the amount of floral trusses I saw on each plant. So I did a generalized linear mixed model to assess the effects on these plants. And this was because in we noticed early on that initial daughter plant weight in grams had a large effect on the outcome of these plants. These plants were rooted for 4 weeks and grown for 8, so they're only 12 weeks old. They're relatively small tray plants when they come out of the treatments. And so we saw that there was no significance across cultivars due to treatment. And that was we repeated the experiment, so that was in both experiments, there are no significance. However, the initial daughter plant weight highly correlated with the amount of floral trusses per plant. So to give you an idea of just what one cultivar looked like, this is what we saw in Chandler. Again, no significance between the 5 treatments in either experiment, and this held true for every single cultivar. And not only was it in the trusses per plant, but the vegetative metrics as well, those being root rating, branch crowns, and final fresh mass. So after not seeing anything from continuous low temperature hours, we wanted to know, can we try to simulate and control an environment these low temperatures in an outdoor facility? So these day-night temperature swings, can we simulate this, and what will that do to the plant? So we hypothesized, again, the non-continuous low temperature from day-night cycles will increase early flowering in our strawberry plants. And we evaluated these treatments on the same 4 cultivars. The rooting and the plant material was exactly the same as what you saw in the continuous temperatures. So I'm just showing the treatments here. Over 6 weeks, the plants were in a growth chamber looking like this, where the short days received a 12-hour photo period and the Everbearings received a 16, again with consistent light and CO2. And at the end, we evaluated for vegetative metrics and flower mapping. This is what our treatments looked like. So this was an average 24 hours for each treatment in the growth chamber. They had a non-chilling temperature of 15 Celsius, and they dipped down at the end of the night period to 4 degrees Celsius. And this is what our photo periods looked like. And so you see varying hours in that 4 degrees period. This is exactly what accumulated, or exactly what they received each day. So we had the treatments accumulating up to 0, 100, 250, or 450 hours. And so that was with 0, 2.4, 6, or 10.7 hours of 4 degrees Celsius for each treatment. And to address a almost definite question I'll get, why are the daily average temperatures different? Are we going to see differences based on that? We ran an initial trial where we had the same amount of 4 degrees Celsius hours per day, but we manipulated the daytime or non-cool temperature to have the same daily average temperature. And we saw similar results to what I will report here. But we elected to repeat this experiment instead because the 450-hour treatment in particular had a temperature swing from 4 Celsius to 26. So it was too much for the plants and it shocked them and they looked really bad. So I'll move on to reporting the amount of floral trusses we saw versus the low temperature hour treatments for each cultivar. So here with Chandler, in our first experiment, we had a peak at 100 hours, that being different from all the other treatments. And in the second experiment, 250 hours had more floral trusses than all the other treatments. So we can assume from this that the optimal amount of hours for most floral trusses is probably somewhere in between there. With sensation, we had a similar pattern in both experiments, with the 100-hour treatment being significantly more than the 450-hour treatment. This makes a lot of sense with sensation being a generally lower chill cultivar. So this is nice to have this confirmed. With Albion, we had it a little more all over the place. Admittedly, in our first experiment with Albion, we had some issues with rooting where the trays remained flooded for too long, so that reduced the quality of the rooted plants going into the treatments. But we didn't see a significant or a significant pattern between the experiments, even though there are significant letters. And then Monterey, we saw in the first experiment a pattern peaking at 250 hours of chilling or of 4 degrees Celsius, but then no significance in the second experiment. And then I wanted to show the same thing I showed for the continuous chill hours, but with this, we had, of course, as you saw in the graphs, our significance with the treatments for a lot of the cultivars. But almost in every case, initial daughter plant size was as much, if not more, of a significant factor on the final amount of trusses in all 4 cultivars across experiments. And so we saw this and we wanted to look at, well, okay, if this size matters so much for the plants at this age, can we separate them by size and will we see differences? And unfortunately, I can't statistically report on any of these because combining the 2 experiments, we had different age of the mother plants for the initial plant material, so they can't be statistically combined. But I just wanted to show trends here that we saw with each cultivar. So I separated the plants based on the median plant size. So they were then given a large or small assignment. And so in Chandler, we do see that the larger plants are much more affected by the lower temperature than the smaller plants are. And our threshold for this size is about 1.6 grams. An idea of what that looks like is a fully unfurled first leaf and a second leaf, at least with a defined petiole coming out of the meristem. That's about the size of a 1.6 gram Chandler plant. With sensation, we didn't see much of a difference in the effects based on the size. And again, the median size was similar to that of Chandler. Albion, we saw, interestingly enough, a peak at 250 hours in the larger plants, and that difference again being 1.6 grams. And Monterey, we saw again quite a peak at 250 hours with the larger plants, and still that peak with the smaller ones, but to a lesser degree. But the size distribution in Monterey was a little smaller, with the large being 1.3 grams and higher. So in conclusion, continuous low temperature does not affect flowering in short day or everbearing plants. However, non-continuous low temperature from day and night temperature swings did increase flower trusses in short day plants. And the initial fresh mass of these plants or of the daughter plants is a greater predictor of trusses in both experiments. But we also saw that larger daughter plants are more affected by low temperature treatments. With that, I want to acknowledge the lab, my advisors, the Phytotron, where all these experiments were conducted, and the Hernandez lab for help with the controlled environment portions of this. So thank you all. Yes.
So combining with Abraham presentation, sitting like that. So your case, you didn't see the continuous change effect.
No, and we actually ran a preliminary experiment where it was after 4 weeks too, just after the rooting, and we didn't see it. So we're like, oh, maybe after 8 weeks, 4 weeks rooting, 4 weeks grow out, we'll see some effect because there's more trusses or more meristems. Still nothing.
Yeah,
So
why then Abraham? New trials show.
I think it has something to do with hardiness and establishment. And not initiated floral trusses.
That floral process because you want to develop the plant that flowers
Yeah.
more, right? But
Yeah.
Chile, I like the low temperatures might have different effects that we can look at.
Yeah.
Right?
Yeah.
But I think what's interesting was combining this with Ed's talk, right? He said he sees more
Oh, there's
impact
something inside.
with he sees like an impact of the
Yeah.
light quality on
Yeah.
everbearers, and we saw an impact of the temperature on short days for early flowering, right? So that might be something that we could look at in the future.
Anyone else?
Any other questions?
So yeah, so it's very physiologically quite interesting, so a continuous chilling doesn't affect, but it is in a cycle.
Mhm.
Because they grow every time different growth.
Yeah, so that's interesting.
Yeah, I know.
I don't know if it is related, but probably not related, I say anyway. So the industry does, chilling in terms of infield chilling.
Yeah.
Yes,
Storage chilling, right?
right.
So infield chilling is a cycle.
That's what we aim for here.
Yeah.
That's why,
So I
yeah.
wonder if actually in storage chilling is doing anything.
But we
now.
don't, so,
Well-
At super low temperature.
so we don't know because we only looked at very young meristem and it goes back to
Mhm.
4 people, right? So if it's older, maybe it does something, we haven't looked at that, right? So if you have like a bigger meristem, we don't know,
But
right?
I always question about the in storage chilling effect, cause if it is 4 degrees C, I understand like doing
Yeah.
something, cause the fish is still working something. Minus 1.5, would that do anything?
it's,
Do anything to sense that chilling in that low temperature, I don't know.
From what I
That's-
understand-
I always wonder, but nobody. You know,
From what I understand, this morning about the hardiness.
yeah, I think, and it also increased vegetative vigor, which you need at the beginning in a lot of field,
yeah, but
field
whose
plants.
is bigger coming from where?
Um, I think correct me if I'm wrong here, but I think physiologically, like the cooler chilling, will give more, assimilate allocation to the crown and roots, and so. the-
Sugar translocated, can be translocated at that super low temperature, minus 1.5.
I don't know.
Yeah,
Yeah.
no, it's not, it's freezing if it is pure water. But
Yeah.
plant tissue never frozen.
Right.
That's why you can, otherwise you shouldn't plant.
So,
So that's not freezing. But
Yeah.
I wonder if any physiological action is still happening under minus 1.5.
yeah, no, I would love if I had a second PhD, I would love to combine. um, yeah. We'll see, FIPCAP 2.0. Yeah,
Yeah.
yeah, so,
Yeah.
Gerald,
But it's very interesting, I really enjoyed it.
oh, thank you.
One of the situations that we have in California that I don't think you have anywhere else is the summer planting window.
Mm.
And you're talking about this super low temperature storage,
Yeah.
that's what we do, right? It's a long-term frozen frigo plants.
Yeah,
And they will be in that condition for months,
right,
Right.
sometimes up to 5 months.
yeah,
And I have seen, but not always, was never able to confirm with the grower or the nursery grower what this was about, but I've seen summer plants get established and immediately put out runners like I've never seen before, just cascading off the beds, just before there's any fruit, before there's much flowering, anything on a summer plant. And you've seen, I don't know, how much you are in the summer planted fields in the
Yeah, I
southern
run all the
districts.
research programs for some plan. Like,
So
my team does all the FPMC, I will walk them every week with reports.
do you see that in summer plants sometimes that the plants will get established and just immediately runner like crazy?
Not recently, not in
I can't
recent,
say that I see it.
not under standard conditions. More often what we see is poor quality from holding them too long in the box, and then high die out because of that mold.
Yeah. So anyways, I haven't seen this very often, but when I did. It's coming back to me now, I'm thinking like maybe that was what caused the excessive vegetative growth.
Yeah,
It's stimulated somehow by the long-term cold storage.
Yeah, yeah.
But it's not
Yeah.
consistent.
Yeah.
a lot of the literature,
On the harvest, exclusive side.
no, you're
It's so dependent on what happens at harvest at low, the conditions at low, right?
Yeah,
So there's all these other variables that stack on top of that.
in a greenhouse, we had, two vegetative starters when planted. In freehold starters, more than 6 months. So when you take out, the plants and then get the freehold plants, that long time storage. Plants grow and initially get flowers because that's the initial flower buds in the plants. But then after, never get flowers, never get flowers. Yeah, we had that overly vegetated for a long time.
Okay,
So we have to come pruning the stuff to just force that to, so we have seen that. Long time.
And then one other comment, Hillary, you were mentioning how the nurseries like to see 400 hours. And yet, Michael, you're not seeing anything beyond 250, at least for those varieties.
Yeah,
Do you think that that's a difference between field and artificial, or?
I think it's the timeline of, I think the 450. It was much worse when we kept the daily average temperature the same due to thermal units, cause the swing was too big. I think it might still be a thermal unit issue where the daily average temperature was 10 degrees there when they're spending 10, almost 11 hours a day at 4 Celsius. So I think if I was able to, say, redesign this experiment to have equal thermal units and expand the time in the growth chamber, I think there could be higher flowering seen at 450, but that's
That was
speculation.
You would still be a PhD in 2 years then.
Yeah, so,
Of PhD students, but, that was taken out of context, so fall planted fresh bearing plants need a minimum of 400 on specifically Monterey as a day neutral in order to force carbohydrate reserves. So that those plants that are being harvested up high can go through the traumatic process of dig, trim, sort, and then get through the winter with the reserves to establish good roots, right? That's a different scenario than Friga,
Yeah.
right? So,
There's all these ways that you can get chill, right? The field chill that occurs in the nursery. Then there's the chill that occurs during the winter months when they're actually planted.
Yeah.
And then there's supplemental chill that growers try to do just by putting them in continuous 34 degrees,
yeah,
let's say for a week or something like that. And then there's the Frigo, super low temperature, and all those things are gonna do something different.
Yeah. It looks like it, yeah.
yeah.
so I have another question, and Sherry and I talked about this very briefly at lunch yesterday, but I guess, so there's a finite budding sites, right? Finite number of budding sites in these plants, potential budding sites, is that true?
Yeah,
That's,
the meristem at each leaf, so it would be, yeah,
Right?
Yeah.
So if you go very deep back in the literature, to stuff that you would have to go like the very back of every university to find, and you look at Brinkhurst's kind of anecdotal stuff when he was doing nursery quality work. It may be that you're killing off all of those fruit budding sites, right? When in scenarios where you're storing for that long. Like it seemed to be some optimization between not wanting the plants to be too precocious and flower early, right? If that makes sense. Versus, and use all the resources for flowering instead of crown development and crown splitting and root development, right? That's why it's all done empirically, that's why we have to do all these chill studies of the release of every, specific to every cultivar. Does that make sense? So it's very nuanced, and I think you're touching on it.
yeah. That was the reason I used low temperature instead of chill too, is the vocabulary, cause we found it's a very loaded term. I presented it at the Strawberry Symposium. I think people thought they were in for a different presentation than what they got, so. Yeah,
Yeah, and other things that we're looking at very young maristem, right? So this is very, like 4 weeks old when they start getting those temperatures, so they're gonna like make the older, if we do it older, before they actually start to like, at least the older ones will be older, right? So. Yeah, it's very young. Maristem we're looking at, so they're there are not that many flower sites that we can manipulate because of the meristem size. Yeah. Cool, thanks, Michael.
Yeah, of course.